Tesla is known for accomplishing big things, so it's not unexpected that Giga Presses may be found at its facilities. These are enormous by any standard, and they will most certainly overshadow your residence. Tesla has and continues to spend much on its Giga Presses. Do those big machines, however, provide an advantage over the competition? Are these massive machines the ultimate game changer for the automobile industry? Welcome to Future Today. We'll discuss Elon Musk's new Gigapress. Before we do, subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. What is the Gigapress? With clamping forces of 61 kilonewtons, the Gigapress is one of the most powerful die-casting machines ever produced. They weigh more than 400 tons, and transporting just one requires 20 flatbed trucks. They are 20 meters long, 7.5 meters wide, and 6 meters tall. IDRA, an Italian manufacturing company, creates them. The firm has benefited from Tesla's patronage on several occasions, according to what we've learned about several current purchases that have yet to be completed. Even though the Gigapress is associated with Tesla's Gigafactory, IDRA initially invented it. Tesla makes its car's chassis in separate sections using the Gigapress. This implies that instead of dealing with hundreds of parts, the car maker has to deal with 3. Suppose it had followed the car industry's long-standing practice of bolting and welding components together. A Gigapress is similar to any other die-casting equipment in that it uses a plunger to drive hot molten metal into a reusable mold. The scale at which a Gigapress does this is amazing. For example, a plastic toy car, the cheaper ones are often built from a single solid piece before the tires are put on. Imagine a car's whole chassis being constructed in the same way, but this time out of metal. The chassis will be made up of no more than 3 elements, with the front and back sections connected by a battery pack construction. The construction of a car chassis with a Gigapress occurs in phases. How does it work? Spraying soybean oil into the mold as a preliminary step is required to make it easier to remove the final chassis. This is necessary for the mold to be reused. A furnace separate from the Gigapress is used to melt the metal. Tesla's chassis is made out of aluminum and silicon. Therefore, it's technically an alloy. The alloy melts at roughly 850 degrees Celsius, and the plunger forces the correct quantity into the mold after cooling to 400 degrees Celsius. A robot opens the mold and moves the chassis into a pool of water for additional cooling to 50 degrees Celsius. Finally, the chassis will be inspected for flaws, and rough edges will be cut before robots drill all appropriate holes. Gigapresses need significant financial investment and a large amount of installation area, so before committing to them, Tesla must have understood the evident advantages. The Gigapress is, without a doubt, a game changer in the care sector. What are the advantages? The most obvious benefit is that it is faster, because despite their massive size, they operate quickly according to IDRA specifications. In less than 100 seconds, the aluminum-silicon alloy may transform from molten metal to a chassis. When you consider all of the labor stages needed to produce and connect more than 100 components, that's lightning quick. It simply implies that Tesla can have more vehicles than the competition. JP Morgan went to see a Gigapress in operation and was blown away. They calculated that a single facility with 10 Gigapresses running continuous shifts could build 350,000 Model Y chassis in a year, utilizing a cycle time of 4 to 5 minutes. Incredible! This is because the Model Y chassis necessitates using 2 Gigapresses. The number rises when the Gigapresses work closer to the maker's specifications. The ones at the Fremont facility have been seen to finish the task in less than 200 seconds. Although they are still being optimized, a new plant may quickly produce 100,000 units in its first year of operation. In automobile manufacturing, such high numbers are practically unheard of. Tesla has stated that it plans to create 750,000 vehicles this year and 50 more the following year. The Gigapress is one of the not-so-secret weapons, with Gigapresses in Fremont, Austin, Shanghai, and Berlin. The goal of over 1 million automobiles does not appear to be insurmountable. The second benefit of Gigapresses is the cost savings. Despite the significant initial investment, the cost of manufacture per car decreases as many operating expenditures are eliminated. For example, a single Gigapress removes the need for around 300 robots. According to Musk, there isn't much coupling or lifting work to be done. After the failure of his drive for a robot-assisted production method for the Model 3, that's saying something. The Gigapresses reduce space requirements by roughly 30% while also lowering manufacturing costs. The size of the body shop has shrunk by around 30%. Given the massive size of the machines, this may come as a surprise. However, the maintenance budget is reduced with less room and fewer robots. Consider the logistics of producing over 100 parts in various places, inspecting them for quality, and delivering them to the assembly facility. With its army of Giga Presses, Tesla can sidestep all of this. When Giga Presses are used, the cost of building a chassis is lowered by around 40%. Remember that Musk intends to produce a cheaper electric car, and with all of the cost reductions, a $25,000 electric vehicle may be more achievable. We're aware that Tesla is establishing research and manufacturing facilities in China with the specific goal of figuring out how to create a low-cost automobile. Giga Presses also increase the resulting product's quality. This is a single piece because there is no bonding or riveting involved. The possibility of misalignment is non-existent, and combining those 70 parts is no joy. It entails sealing between them, which Musk describes as a nightmare. Tesla can now move on to structural battery casings, which it has been aiming to achieve for some time, thanks to Giga Presses. Tesla has finally worked out how to do it, he stated during Tesla's Battery Day event. These battery packs function as the vehicle platform's stressed center component, connecting the front and rear die castings. Tesla is moving forward with structural batteries because they are lighter and pack the cells more efficiently. According to Musk, the present method of packaging battery cells is compared to a sack of potatoes with little structural merit. According to Musk, the structural battery arranges the cell like a honeycomb, making it highly rigid. It also has to be segregated from the rest of the car and protected from vibration and stress loads. Disadvantages: in most circumstances, manufacturing a bigger casting should be advantageous in efficiency and cost. However, depending on the application and specific conditions, the pros and disadvantages may alter. Casting bigger single components for autos, for example, has obvious advantages. However, now in the event of an accident, automobile repair and maintenance might be challenging. Because of slight damage, you wouldn't want to rebuild the entire front or back chassis. As a result, automakers interested in Gigapress may need to solve difficulties like these before pursuing it. How do the components work? The Gigapress is more of a machine than a die casting setup. It is outfitted with all the necessary machines and systems for die casting. Tesla's Gigapress has the following components. Ovens. 2 ovens in the Gigapress handle the aluminum alloy. One is a melting oven that runs on natural gas and has a temperature of 850 degrees Celsius. Another oven, powered by electricity and runs at a temperature of 750 to 850 degrees Celsius, stores the liquid metal. Vacuum tank. The Gigapress creates a vacuum within the mold with a 4,000-liter tank. Fondirex, a Swiss business that started the vacuum technique for high-pressure die casting, manufactures it. Quenching tank. The quenching tank quickly lowers the casting temperature to a safe level. It enables the attainment of specified qualities in metal casting. Trimming device. There are mechanical trimming presses and laser trim for quickly cutting superfluous metal linked to the casting. Metal scrap recycler. To use the scrap metals, there is a recycling mechanism in place. The scrap aluminum is shredded with offcuts used in subsequent casting cycles. Devices for inspection. Various inspection instruments like CMMs and X-ray machines are used to inspect the finished casting. Tesla's Gigapress unit seems to be expanding in the foreseeable future. With this, Tesla and strategic partner IDRA will have to put in a lot of work to make a big adjustment to build an incredible machine that outperforms. The Gigapress was the most challenging hurdle. So, is there any car manufacturer that can beat Tesla? And what do you think of Tesla's Gigapress competitive edge? Let us know in the comments section below. That's all for now. Don't forget to subscribe to our channel to get updated with everything on future technology. Thank you for watching.